Okay, I'm going to continue with meshes and deal with Grasshopper for Rhino, the ABCs, 1, 2, 3s. And we're basically slowing down and making larger strips for these nodes so you can understand them. We're going to start with, sorry, not meshes. We're going to talk about intersections. So let's jump on in and see what's happening. First one, right here, take this off, is basically the Brett plane intersection. So what I did was I connected that with this little jump tool over here so you can see where it connects. And what I did was I took a cylinder, which is pretty simple. I capped it, so that would be my Brett. And I took a plane and I then rotated it on a different angle to make it a little more interesting than a boring plane on the axis angle XZ. And we have control over that as we turn it. And what's nice is as you do that, I mean, these are great little scripts, at least in my opinion. And we're going to move that up, in a sense, having a little control on a Z-plane as a domain, but also as a range. How many times we go up with that. And in doing so, we end up with a pretty cool form of this being sliced across that, having control over how we want to slice, on what angle, and how many directions we want to slice that geometry. Pretty cool little piece of geometry, a nice little script. Wrap your head around it, figure out these nodes in full detail, invent your own little snippets, and send them in for a nice little loft, and there you go. Nice and easy. Invented by just play. And that's what you need to be doing in Grasshopper. It's not get so stressed over what was the initial idea. Jump in here and have some fun making your geometries, loft them for visualization, and that's it. Nice little example of a Brett plane tool. Contour, well, that's pretty familiar for any fabricator. Take a point, generates a point that you will then set the distance from contouring that piece of geometry. It turns out it's the same boundary representation of that cylinder. So if I want to grab that cylinder along with these lines, I can set the distance between there and contour any way I want in order to go to fabrication. Nice and easy. Let's go down to contour extended. Pretty cool little tool. If we grab in there, you have a lot more control over the offset or distance. What I'm going to do with that is grab that plane, be able to offset that at a different height. So not only do we have that initial Brett point, we're going to come back up to there. We're going to want to use that to offset the distance. You can do offsets or you can do distance. It doesn't really matter. But you have two curves here because what did I do? I took one and I brought in two. So the reason there's two splitting here is I took the initial plane and then I also moved that plane. So I have it in two locations. And in having it in two locations gives me two lines. So that's why I end up with two. So that's a little subtle little thing just to play with the script. Over here, we've got some geometries that didn't come through for some reason. Probably because I took this off. So what I'll have to do is activate all this. Enable, even though we don't need to see it all. And that way this script will run. We're jumping down into the curve plane tool. And so we use a little jump tool, and there it is over there, and there it is over there. So what do we do to do that? We set up a plane. I actually chose a plane on the XZ plane, and I brought that in as a rotation and rotated it back. That will be my plane that I take my points and my curve, and basically that curve that I used from an earlier script, it's one that we extended by scaling larger. It shows me where that plane and that line come in contact with one another. Pretty darn simple, and it actually gives you the parameter of where along that line reparameterized between 0 and 1 is. Nice little example. And then param 2 is, how does this work? Yeah, I have two parameters on there. The one is the parameters on the line curve, and then one is the UV point on the plane. So those are cool little points because you could actually draw a line up between those two and use that as a geometrical reference between the two if you want to do that. So it's a small little line, subtle little line, but it's there. Get into here, figure it out. What do we have here? We have a line plane tool. It's going to jump over here and do a little bit of geometry. I think I did a very similar thing. I'm going to take my curve that we know well, but I'm going to grab the endpoints of that, and I'm going to draw a line between that. The reason I did that was my curve was, I guess I didn't have to do that. I'm just using the same curve anyhow. But in having that line, between the two, the full length of it, and then taking that plane that's there, taking that rotated plane that I had there, you're basically making a line plane, and you'll notice that that line plane, what I did was I took what potentially could be a curve, I took the endpoints and made a line between it so it actually wouldn't be a curve, it would be a straight line, and then you'll realize that the line plane tool and the curve plane tool are pretty much the same things. So as we grab these bits of data, we're going to realize they're very they should be similar in their geometry, at least in their formation, to how the other one was. And you can draw that line between as well and compare those two if you wanted. Anyhow, that's a nice little tool, but yeah, curve plane and line plane are going to be very, very similar in how you treat it. That being said, that was the curve. Let's jump down here and let's jump into here. We've already done that one. We're going to use this script to play off of mesh plane. And mesh plane, we're definitely going to need a mesh. So how am I going to generate one? I'm just going to make one very, very basically. And then what I did was I grabbed a plane that I put into a move tool that I could actually take where those two intersect. Now, of course, they're not showing anything right now because I've got it placed at the center. But as I start to move that in the x-axis, you see that line that follows along that mesh. And that's your intersection along that mesh. So you could just leave that. You'll see basically a line that moves along that mesh as a plane. Very simple tools, but get in and play with them. The next one is plane. So I grabbed a plane here, and I actually chose to grab this plane here, and then the intersection between them becomes this little small section, a unitized line between the two, just 1 millimeter between them. Interesting to play with. This plane, I so choose to bring it in. Not only did I bring that vertical plane in, I brought out this horizontal plane, because this is going to want 3 planes, so I brought in actually this plane that I had on an angle. And those 3 planes come together and they form a very interesting thing. That between them from a center point, let's watch what happens here. We've got that point that begins there, but we have this line, and that line, which is hard to see. It's actually running back as you follow these lofted sections. You're going to see that section, this section. I think my line changed a little bit. Let me just check that out. 1, 2, 3. 1, 2, 3, 4. Hang on, I got to set this one right because I had it a little mixed up because I was playing with it. 3, 4, and then 5, 6. So you got lofted, 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 and they're all the triangles that come off of those 3 planes that are wedged between those. So that's an interesting little tool. Use that if you want. Plane intersection. Get in the habit of figuring it out in full detail. Plane region's kind of nice because what is a plane region? Well, you're going to basically take here, and I'm going to go down to the end, the plane that you want to end up using, which is this one, but I'm going to control it by the bounds of this plane, and this plane. So I chose between it. And what's nice is as I move those around, say I want to manipulate this one, you're going to end up being able to slice that region back from that. But you set up the angles to build a pretty interesting controlled little piece of geometry. And I'm using a polygon to start to build that plane. That's actually what I'm trimming. So very good tool here, the plane region, to actually get into trimming different region tools with planes. I would use that. Now this is a really cool tool, at least in my opinion. We're almost done. It's the IsoVis tool, and I'm probably not using it the way it was intended, but what I did was I grabbed a polygon. I can change that shape. I populated it with 6 points, and I have a seed that changes it, and I build circles like objects. And what I like to do on this one is go into top view and say, okay, those are the objects. And how do I get through it? How do I shine light through that? So my construction plane is just off my XY, so that's pretty easy. And the count is in the IsoVis tool. We better click on it. Sorry, I got it too far over, so when I click on it, hit help. The count is the sample count of what you're actually using. So you're going to grab that geometry around these circles. I'm going to try and show this. How do I end up getting stuff into there? How do I shine light into these caverns? And it actually becomes a pretty cool thing, because if I grab those points and I actually take them to interpolation, you'll see you get these very interesting structures ballooning out and ballooning in. And watch what happens when I start to play with these sliders. So as I change the seed, yes, some light comes in. You see how it kind of ricochets in around those objects? So I'm definitely going to use this as a kind of geometry building if I think of these as a floor plan to a unit. Maybe that's not what it's intended for, but what a way to think about the point count to have an influence of how to gather. I don't know if you're thinking bubbles or water or pretty cool stuff. And one thing I haven't figured out. This one here for the radius doesn't have much effect on it, but it's obviously, well, actually, it would have an effect on the outer radius when I get into it. So I've really kind of started to think about that between those curves as they balloon out. How far do they really jump and come into the internal of that core? And of course, if I change my seed count, I'm going to change trapping that information and letting it out. So what does that mean as a physical ability to simulate something? That's why I said really cool tool. So, I have yet to conceive, and really, it's not about being taught. It's not about following tutorials. It's about what you see that doing. The IsoVist. The other one is the IsoVist Ray, which is the same in a sense that I would grab, and not as exciting. But take a look at the data in this one, which can be very interesting. I'm going to grab the. I'm going to use the tool, but what I'm going to do in it is I'm going to grab a line and I'm going to shoot it through those obstacles. So those obstacles I'm going to blast through this line. Now, where on that line does it hit the point? And of course, that's the last point grafted to where it would be. And I think that's pretty cool. And then you've got, that's the point, that's the distance. You got one item, and it's a circle. The distance away from it. What happens when I end up grafting that, which is pretty cool? I'm just going to drag this over and graft it. Is end up with all these points of where they hit those geometries and kind of go through. And I think that's pretty interesting to think about that. And I need my circles to do that. There they are. So all the ones that are hitting, where along that line, what's the parameter along that line of where they're actually going through. So once again, these last two, I think of them extremely geometrically in a sense of IsoVist, where's it applied, what do I need for data for that one, and then what's the IsoVist Ray. And to me, these are things leading towards more simulation, sun studies, water studies, air studies, noise studies, sound studies. Like, that's where Grasshopper is amazing. It's as highly a conceptual exercise as you want to make it. What can you do with those basic things? And here I am at 12 minutes. I'm going to throw that into a group. I'm happy with analyzing those and starting to conceive of what I can physically do or not. If you don't have that, I mean, that's the main point of it, is just don't be so quick to, maybe I'll just leave it there because this is the blue that I actually like as the cool script along with the other one. But this one I'm definitely going to use in a sense of trying to figure that out. You're left with some pretty cool geometries. What is it that's happening here? Kind of nice. All right. Thanks for watching. I'm going to keep going. And what am I going to keep going with? Intersections after mathematical. I may go into the physical intersections. The regions are going to allow us to move beyond line and point, and then we're going to move into 3 dimensions as we start to intersect. And I think the farther you get into 3 dimensions, the less and less opportunity you have to really analyze and think and create new things. You end up doing things that are set in place that work very well. So really hold to the math, then get into the physical and regions and shapes. All right, that's